See the fifth one? You have sine to the power of 4x, correct? See, when you have sine to the power of 4, we write it as sine square x into sine square x dx. Alright? Of course, you cannot take anything beyond the sine square. So, what we do now, take it as 1 minus cos 2x divided by 2 whole square dx. Correct? So, you can write this as, see, that denominator 2, when you square it, it's going to become 4. So, 1 by 4 integral of 1 minus cos 2x whole square dx. Right? Use a minus b whole square. So, you'll get this as 1 by 4 integral of 1 plus cos square 2x minus 2 cos 2x. There's a plus and minus, split the integral. That means you are going to get 1 by 4 integral of 1, or you can just call it as dx, right? Minus 2 integral of cos 2x, correct? Then finally integral of cos square 2x. See, when we do cos square 2x, again you have to use the same logic, correct? So what we are going to get, 1 by 4 into x minus 2 divided by 2 into sine 2x plus integral of cos square 2x, right? So now you'll get it as 1 by 4 into x minus sine 2x plus this we can write it as 1 plus cos 4x divided by 2. Remember how we used to do 1 plus cos 2x divided by 2? Likewise, this is going to be 1 plus cos 4x divided by 2. So, 1 by 4 into x minus sine 2x plus half integral of 1 plus cos 4x, right? Take the half outside. Now you can multiply it here in the sense 1 by 4 x minus sine 2x plus half into, you have integral of 1 plus cos 4x. That means you have integral of dx plus integral of cos 4x, right? So this is what we have. Now finally you guys can do it quite easily now, correct? You'll have 1 by 4 into x minus sine 2x plus half into x plus 1 by 4 sine 4x, correct? Multiply the half into the inner part. So you have 1 by 4 into x minus sine 2x plus x by 2 plus sine 4x divided by 8 plus c. Final answer. This is the final answer. Okay, now small changes you can make, that is x plus x by 2, you can make it as 3x by 2. So if you do that, then you can say that the final answer is going to become, see, 3x by 2 into 1 by 4. So 1 by 4 into 3x by 2 minus sine 2x plus sine 4x divided by 8 plus c. So this is going to become the final answer for the fifth one. Fair enough? Now let's do the sixth problem. The sixth one, tan power 4x, right? So tan power 4, you can write it in two ways. Fair enough? So the first way what you can write is you can write it as tan square x whole square, where tan square x you can write it as secant square x minus 1. Okay, so that is one way of doing this. Or one more way is there. See, you have integration of tan to the power of 4x dx, right? So in this case, integral of, you have tan square x into tan square x, correct, dx. Integral of secant square x minus 1 into tan square x, correct. Now, suppose if you take tan square x or tan x as t, substitution method you can try. If you do that, then it might be a little hard for you. So what we do now is multiply. That means secant square x into tan square x minus integral of tan square x, right? So integral of secant square x into tan square x, integral of secant square x minus 1 dx, correct? So what will you get now? You have integral of tan square x into secant square x minus integral of secant square x plus integral of dx, isn't it? So in the first part here, take tan of x is equal to t, then secant square x dx is equal to dt, isn't it? So you'll get integral of t square dt minus integral of secant square x plus integral of dx, right? See, integration of t square is what? T cube divided by 3 minus tan x plus x plus c. So finally, what is t? Tan x. This is going to become tan cube x divided by 3 minus tan x plus c. So this is going to be the final answer for the 6th question. Okay, now let's do the 7th one. Problem. See here, cos x by 1 plus cos x, correct? Now convert this in the submultiple angle. All right. See, you have cos x divided by 1 plus cos x. Now you can write this cos x, the numerator, as cos square x by 2 minus sin square x by 2. All right. Now 1 plus cos x. Now 1 plus cos 2 theta is basically cos square theta. This is going to become 2 cos square x by 2. All right. Now again there are two ways of doing. One is individually divide. So when you individually divide, you'll get half of, okay, so or take the 2 common outside. Cos square x by 2 divided by cos square x by 2 minus sin square x by 2 divided by cos square x by 2. Okay, cancels out, get it as 1. So you will get it as half 1 minus tan square x by 2, isn't it? 1 minus tan square x by 2. Tan square x by 2, you can write it as secant square x by 2 minus 1, right? So you will have half of 1 minus secant square x by 2 minus 1. So minus of minus becomes plus 1. Got it? Minus of minus, right? Because it's minus tan square x by 2. So minus of. So this is going to become now half 2 minus secant square x by 2. Now we can integrate. Okay, so we get I is equal to half integration of 2 minus secant square x by 2 dx. Split the integral, you'll get half of 2 dx minus secant square x by 2 dx. Correct? So this is going to be half 2x minus, see, secant square x by 2. Correct? This is going to become tan of x by 2 divided by x by 2, which basically becomes 2 plus c. Yeah. Now divide this, you will get the answer as x minus tan x by 2 plus c. This is the answer for the 7th one. Understood? Let's do the 8th question now. See, in the 8th one, sin square x divided 1 plus cos x. Correct? Now, sin square x, we can write it as sin x whole square by 1 plus cos x. Simplify. This you can write it as, see, 2 sin x by 2 cos x by 2 whole square. Okay? Divided by 2 cos square x by 2. Fair enough? Now, numerator becomes 4 sin square x by 2 into cos square x by 2 divided by 2 cos square x by 2. 2 times, then cos square x by 2, cos square x by 2 cancels out. Right? So, what do we end up with? 2 sin square x by 2. That's all, right? We can't integrate it. What do? We convert this in terms of cos 2x form, right? So, you are going to write this as 2 into 1 minus cos x divided by 2, right? 2 and 2 cancels out. So, finally, what do we get? I is equal to integral of 1 minus cos x. That's all. See, the problem reduced to just 1 minus cos x. So, now I is equal to integral of dx is x minus sin x plus c. That's all. The answer is this, x minus sin x. Yeah. Now, let's do the last one, the 9th one. We'll do this one. You have cos x minus sin x by 1 plus sin 2x, right? Now, 1 you can write it as cos square x plus sin square x, right? And sin 2x you can write it as 2 sin x into cos x. So, basically in the denominator, we will have cos square x plus sin square x plus 2 sin x into cos x. Correct? So, you get cos x minus sin x divided by, guys, look at this one. Don't you think this is of the form a square plus b square plus 2ab? Correct? Which is a plus b whole square. That means this is going to be cos x plus sin x whole square. Right? Now, this is your form or this is your problem. Now, we can't directly do it. So, what do? We need to simplify it. Right? The simplification part is very important in these kind of problems. So, when you have cos x minus sin x divided by cos x plus sin x whole square, one way of solving this is where you divide numerator and denominator by cos square x. Okay, divide numerator and denominator. So, if you divide that, then you will get cos x minus sin x by cos square x by cos x plus sin x divided by cos x whole square. So, you will have cos x by cos square x minus sin x divided by cos square x divided by 1 plus tan x whole square. Got it? So this is going to become, see, 1 cos and cos cancels out. So you're going to have secant x minus tan x into secant x by 1 plus tan x whole square. Okay. Or secant x into 1 minus tan x by 1 plus tan x whole square. Right? Now we got in terms of tan. Suppose if you are going to take in terms of tan itself, we can take tan x as t and we can solve it. Correct? Let's do it now. See here, you have cos x minus sin x by, see the denominator, 1 is there, correct? So let's write it as cos square x plus sin square x plus 2 cos x sin x, correct? If you look at the denominator, see this a square plus b square plus 2ab, correct? Which is a plus b whole square. So here cos x minus sin x by cos x plus sin x whole square. Now I will call it as this with dx, right? Now denominator, you take it as t, like is in your substitution. If you take the denominator as t, we will have cos x plus sin x as t. So minus sin x plus cos x dx is equal to dt. So numerator is going to become integral of dt divided by t square. Very simple. T power minus 2 dt or t power minus 1 by minus 1 plus c, or minus 1 by t, which is cos x plus sin x plus c. This is the final answer. Understood? So whatever problems we have done so far, remember there are different ways of solving it. I'm just showing you one of the ways. Fine. These are certain problems where we are using just trigonometric identities. Fine. Now in the next video, you will learn few more types of identities, more like formulas or different types of results. Fine. So let's do those in the next video.